Hello, sixth graders. Today we're going to be adding and subtracting fractions. Let's take a look at some of these things. We're going to rename each mixed number into simplest form. Let's see, how did they solve this right here? Well, all they did was they took a look at this 6/5, and they realized that 6/5, when they rewrite it, 5 goes into 6 one time with 1 left over. Then they added this 3 to it. 1 plus 3 is 4, 1/5 is left over. Let's move over to this for me. How many 8s go into 16? Exactly 2 8s go into 16. Anything left over? There isn't anything left over, so 2 is your answer there. We have 9 and 5/3. We have to write that as a mixed number in simplest terms. Let's take a look at the 5/3 here. How would we rewrite that? 3 goes into 5 one time. We have 2/3 left over. Let's add a 1 to this 9, so we have the answer 10 and 2/3. Here's another one. We have 1 and 7/5. Well, 7/5, if we wrote that, how many 5s go into 7? 1, and 2/5 is left over. I have a 1 still, so I'm going to add the 1 plus the 1, 2 and 2/5 would be my answer. I don't know why that 0 is there. I need to get rid of that. I meant to circle the 1. Here's another one. 4 and 6/4. Let's take a look. 6/4 would be the same as 1 and 2/4, which would be the same as 1 1/2. But we have to add this 1 to the 4, so this is 5 1/2. How about here? 10/6. The problem is 5 and 10/6. We'd write this as 1 and 4/6. We'd have to reduce 4/6 to 2/3, 1 and 2/3, because 4 divided by 2 is 2, 6 divided by 2 is 3. We add to this 5, so we have 6 and 2/3. Now I'm going to show you exactly what I did here, because we're going to work opposite. Watch closely. 5 times 3 is 15, plus 6 is 21 over 5. Do I get the same thing? 5 times 4 is 20, plus 1 is 21 over 5. That means I didn't make a mistake. Okay, this one's already done for us. Let's take a look here. 3 times 9 is 27, plus 5 is 32 over 3. 3 times 10 is 30, plus 2 is 32 over 3. 5 times 1 is 5, plus 7 is 12 over 5. 5 times 2 plus 2 is 12 over 5. I think you understand how I'm checking my work right now. 4 times 4 is 16, plus 2 is 22 over 4. Ooh, did I make a mistake there? It's 22 over 4. 5 times 2 is 10, plus 1 is 11 over 2. I didn't make a mistake, because look, divide by 2 is 11 over 2. Last one right here, 5 times 6 is 30, plus 10 is 40 over 6. 6 times 3 is 18, plus 2 is 20 over 2. If I divide these two by 2, I also get the same problem. Let's keep moving on here. Okay, fill in the missing numbers. So let's take a look here. I'm taking this 2, so this 3 gets reduced to a 2. What that means is I'm taking an 8 over 8 away, and I'm putting it into the fraction. I already have a 3 there, right? So I'm adding an 8 to this, so my answer is 11 over 8. Over here, let's take a look. Each one of these 4s, this 4 right here is actually worth 6 over 6, 6 over 6, 6 over 6, 6 over 6. That's what that 4 equals. The reason why I'm writing this out is so you understand, okay? 1 plus 1 plus 1 plus 1 is 4. But what I'm doing here is there was a 5 here, 4 and 5, 6, and they turned it into blank with 11 over 6. They added a 6 to this 5 to get to 11. So what they did is they took one of these away, and they put it into the fraction, just like they did right here. They put it into the fraction. So that means I'm left with 1, 2, 3, 3 left over, and 11/6. Let's take a look here. They took one of these 2's away. They made it a 1. But each one of those 2's is worth 9 over 9 in this problem. I already had a 1 in the problem. 1 plus 9 would be 10 over 9 is my answer. Moving on over here. It looks like here they took a 3 and they added a 7 to it to get to a 10. That means they took one of these 6's away and made it a 5. Because each one of these 6's would be 7 over 7, 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 7 over 7. We took one of these away, so now we're left with 5. 1, 2, 3, 4, 5. They took that 7 and they stuck it into this problem. Hopefully this is making a little sense here. Take a look here. They did the same thing here. They took one of these away and they made it a 3. Each one of those is worth 5 over 5 because 5 is my number. So we're going to do 3 plus 5, which would be an 8 up here, over 5. Over here, looks like they're leaving it up to us on what we want to do. Let's change this to a 6. If this is a 6, I'm taking one away from here. I already have a 2, so it's 2 plus, and in this problem it's a 3. So that means my answer up top here is a 5. 5 over 3. Let's move on. So we're going to be adding. The nice thing about this, we're adding 2 and 5/8 plus 6 and 3/4. They already have the problems stacked for us, which is really convenient. We've got to find common denominators. This is out of 8. 8 times 1, 5 times 1 is 5/8. So this top problem is 2 and 5/8 plus 4 times 2 is 8, 3 times 2 is 6, 6 and 6/8. If I add these up, I get 2 plus 6, the big numbers, which is 8. 5 plus 6 is 11 over 8. I cannot leave my problem like this, but I have to work it out. 8 and 11/8. If I take 11/8, kids, I have to change this into a fraction. It would be how many 8s go in 11? 1. What's left over? 3/8. I'm going to take this number. I'm going to add it to this 8 because this 11/8 is the same as that. 8 plus 1 is 9, and I have 3/8 left over. Here's another one. 7.5 minus 5/8. Now I have to stack my fractions because it's not stacked for me. I'm going to change half, and I'm going to change 5/8. Okay? Putting them both into 8 because 2 and 8 both go into 8. Times 4. 2 times 4 is 8. 1 times 4 is 4/8. So this is 7 and 4/8 minus 4 and 5/8. This is what I love about this problem. Watch really, really closely, okay? It's the first time we've seen this year, which is kind of my favorite, so watch close. 8s are my common denominators. My answer is not 3 and 1/8. The reason why is I can't take this 5 away from the 4. I can't do it. So this is what you have to do. Watch closely. I have to borrow one of these 7s into the 8, just like I was doing on these problems right here, how we're borrowing to make them bigger, how we're borrowing. So watch close here. I'm going to cross off this 7, and I'm going to make it a 6. But each one of these 7s is worth 8 over 8. So I'm adding an 8 to this 4. So now I have 6 and 12/8. Hopefully you guys all caught along because there's already a 4 there. Because I have an 8, this is the same as 8 over 8, 8 over 8, 7 times, right? 8 over 8. I don't want to put them all there, but you know what I mean. I took one of them, I put it back into the fraction. And now I can subtract it. So it's just like borrowing with long subtraction. Now, excuse me. Now I can subtract. 6 minus 4 is 2. 12 minus 5 is 7. And then I have my 8. There is my answer, 2 and 7/8. It's much different than 3 and 1/8. Okay? Here's now 8 minus 3 and 2/3. Watch closely here now. I'm going to take this 8 and I'm going to make it a 7. Because this is a 3, I'm going to make this a 3 over 3. Just because this is a 3, I made it a 3 over 3. Because now I don't have to find common denominators. But I had to borrow to make the problem easier. Now I can simply solve. 7 minus 3 is 4. 3 minus 2 is 1. And I have 3 as my common denominator. Let's keep cruising along here. I have 6 and 5/6. I know, sorry, this is hard to read. And 5/6. And 3 and 3/5. Okay? Let's find common denominators and let's solve this. We have to stack the fractions. I'm going to take 5/6 and I'm going to take 3/5. I'm going to stack them. I'm going to find common denominators. Let's put them both into 30. Because 6 and 5 both go into 30. 6 times 5 is 30. 5 times 5 is 25. So this first problem is 6 and 25 over 30. Plus 5 times 6 is 30. 3 times 6 is 18. 3 and 18 over 30. You see how big of a number we're getting? It's okay. 6 plus 3 is 9. 25 plus 18. 5 plus 8 is 13. Add these up, we have 43. So we have 43 over 30. So our answer is 9 and 43 over 30. But we can't leave it like that. So we have to figure out, we have to break down 43 over 30. How many 30s go into 43? 1, and 13 over 30 is left over. You see why? 30 goes into 43 one time, 13 over 43. And now we're going to, don't forget about this 9. Add the 9 to this. So your answer is 10 and 13 over 30. That's how you solve it. Let's keep cruising along here. Got some subtraction here. I love this problem because look, we have to borrow. We have 12s here, right? 12s are my common denominator. I have a 5 up top, so it's 6 and 5 twelfths minus 3 and 11 twelfths. We have to borrow. I can't take 11 away from 5. So what I'm going to do here is I'm going to cross off this 6. I'm going to make it a 5. This is where kids wonder, what do I add to this 5 up here? I have to add a 12 to the 5 because 12 is my denominator. 5 plus 12 is 17 over 12 minus 3 and 11 twelfths. Now I can subtract. 5 minus 3 is 2. 17 minus 11 is 6 twelfths, which would be the same as 2 and a half, because 6 twelfths, if you divide them both by 6, 6 divided by 6 is 1, 12 divided by 6 is 2. Keep going. Here's another one you get to borrow on. Watch closely in case you're still struggling. I can't take 7 away from the 3. So I'm going to cross off this 4 and I'm going to make it a 3. I have to add an 8 to this 3 up here because 8 is my denominator. 3 plus 8 is 11 eighths minus 3 and 7 eighths. Now I can subtract across. 3 times 3 is 0. 11 minus 7 is 4. And then we have 8. Obviously, you're not going to write this answer with a 0 in it. And you can't leave your answer with 4 eighths. You're going to divide by 4, divide by 4. So I get 1/2 as an answer. Look at this fun problem. I'm going to do one long problem here and then we will be done. So watch closely. We have 6.5 minus 4 plus 2.5. Watch closely. In this problem, we don't have to break it down. We sure can, so watch. 6.5 minus, let's make this 3 and 2 over 2. You guys see how that works? Now you're making it more confusing. So in this problem right here, you can simply just subtract the 4. So if you think about it, 6.5 minus 4 would be 2.5. I'm going to add up the 2 and 1/4 as well. I have to stack these fractions up, so watch carefully. 1/2 and 1/4 both go into 4. So this would be 1/4. This would be times 2, times 2, 2/4. So this is 2 and 2/4 plus 2.5, 1/4. So your answer is 4 and 3/4 would be your answer. Okay. Hopefully this helps a little bit with your adding and subtracting of fractions. The biggest key to this is you're borrowing when you're subtracting fractions. You don't have to borrow when you're adding fractions, just when you're subtracting fractions. Hopefully this helped. Good luck on your math, and I look forward to doing some mixed number fractions with you in math today.